Welcome to our training on industrial automation and machine learning. We'll be starting with an introduction. We're going to be going over AI-powered analytics, machine learning, how AI helps manufacturers, smart sensors, machine learning, industrial robots, and applying industrial machine learning. If you have any questions, please enter them into the chat box and we'll be addressing them at the end of the training. If you're working on any applications you want to go over, please let us know. I'm Maria Santella, Sales Manager for ICP DAS USA, and I've been with the company for 11 years. I previously held positions here as Application Engineer, Technical Sales Engineer, and Web Developer. I have Robert Murao, one of our Senior Application Engineers, here with me, and he's been at ICP DAS for 11 years and has extensive experience in the automation industry. He'll be giving an online demonstration later in the training, demonstrating how IoT Star cloud software has machine learning capabilities. We manufacture our products in Taiwan. We can ship within 7 to 10 days. And ICP DAS was established in 1993. ICP DAS USA was launched in 2001. We offer ROHS compliant lead-free products. We have our ISO 9001 certification, ensuring we meet product statutory and regulatory requirements. We provide industrial control products and data acquisition system solutions that are low DC voltage and operate in extreme temperatures. We have a knowledgeable team. We provide free consultation and product specification. We also provide free tech support. We help with questions, setting up equipment, and troubleshooting issues. For large volumes of equipment, we provide configuration services, including setting the IP addresses, baud rate, channels, and other settings, making installations faster and easier for you. Our products are robust, very reliable, and come with a 1-year warranty. We also provide free Easy Data Logger software for PC-based monitoring and control systems. We also have eLogger software, and it has the added web HMI feature that allows you to publish your application for remote viewing over a web page. Artificial intelligence is an area of computer science focused on the simulation of human intelligence processes by machinery and computers. AI makes it possible for machines to learn from experience, to perform tasks on their own, and mimic human reasoning and problem solving. Artificial intelligence includes speech recognition capabilities, customer service tasks, recommendation engines, and autonomous vehicles. More and more, manufacturers are applying data and analytics to their operations and processes to optimize supply chains, improve forecasts, develop propositions, and to monitor machine usage and reliability. AI-powered analytics help with learning how users search, what they're searching for, considers information known about users, and ensures only relevant insights reach appropriate users. AI-powered systems analyze data from many sources and offer predictions about what works and what doesn't. Data patterns are discovered and analyzed, so decisions based on the data can be used for automated actions. An example of artificial intelligence in industrial automation is predictive analytics, which is the practice of making predictions about future based on historical and present data. It's utilized in experience management programs to model how decisions will impact a company and has the potential to change how decisions are made in organizations. The more data that's collected, the more accurate your predictive analytics process will be. This chart here shows the steps to any predictive analytic process. It provides trending predictions and patterns from the data. Machine learning is a field of artificial intelligence and computer science involving the use of data and algorithms to imitate how humans learn and improve. It focuses on the capability of a machine to imitate intelligent human behavior. It allows systems to learn from past performance without explicit programming, so they can access data and use it to acquire knowledge on their own. Machine learning methods use AI-powered analytics to discover new patterns, correlations, and insights in data. AI analytics is the data source used in the AI automation process. Machine learning enhances analytics capabilities in terms of speed, the volume of data that can be examined, and the level of detail that can be tracked. Machine learning algorithms are the foundation of AI analytics, which continuously track and examine vast volumes of data like scale, speed, and accuracy. Traditional data logging systems were done manually with a paper and pencil. An operator went out and visited tanks, took visual readings of tank measurement levels, and wrote down the measurements at different times of day, every day of the week. With data acquisition equipment and software, data logging systems have been automated, so the levels are recorded into spreadsheet format for trending and analysis. In manufacturing-based data logging systems, data acquisition is used to take measurements, sensing the position or location of objects in the manufacturing process, turning motors or equipment on or off, decision-making, and more. We provide data acquisition equipment that communicates over many different protocols, including Modbus RTU, Modbus TCP, Ethernet IP, EtherCAT, Profibus, Profinet, CAN Open, DeviceNet, Wi-Fi, Zigbee, and more. Artificial intelligence influences our daily lives and workplaces. Many of us use image recognition of our face to unlock our cell phones. Search engines use AI to improve our search results. AI is helping with making predictions, identifying trends, analyzing data, and making improvements. This technology has proven very important for manufacturers who produce the most data of any industry. Traditionally, most of their data was discarded. AI is assisting manufacturers in making the most of massive data to enhance decision-making. AI's role in manufacturing is to make it smarter through the use of sensors, quick data collection, and analysis. Traditionally, much of the data for improving industrial automation machine performance was done and collected manually by analysts that evaluated processes and made suggestions for improvements. With machine learning and AI-powered analytics, data collection, the processing of the information, data analysis, predictions and suggestions are done automatically. In some industrial automation-based control systems, machines are improving their own performance. With AI-powered analytics, historical information and machine learning systems have increased in efficiency by triggering processes, pumps, valves, heaters, and fans, and other equipment to turn on or off at different intervals based on historical information and prediction information. AI helps manufacturers with data acquisition, data collection, examining workflows, identifying inefficiency and issues. This all saves time and money. Machine learning algorithms can be applied to monitor systems and can tell us when a machine has issues or may experience problems at certain intervals. We provide .NET programmable controllers, and you can also use our data acquisition equipment with PC-based systems running .NET programs. ML.NET, developed by Microsoft, is a free open source cross-platform machine learning framework made specifically for .NET developers. With ML.NET, you can develop and integrate custom machine learning models into your .NET applications without needing prior machine learning experience. ML.NET is an extensible platform with tooling in Visual Studio, as well as cross-platform CLI that powers recognized Microsoft features like Windows Hello, Bing Ads, PowerPoint design ideas, and more. ML.NET by Microsoft also has built-in tools that allow you to easily add machine learning into your application, so you're quickly and easily able to add in features like speech recognition and image recognition so you can improve and expand your user experience. Tools are available that help with analyzing the sentiment of customers, recommending products based on purchase history, price predictions, customer segmentation, object detection, fraud detection, image classification, and sales forecasting. You can enable your systems to automatically learn from data and past experiences in order to spot patterns and make predictions with little to no human involvement. Some benefits of AI in manufacturing are AI is streamlining production, increasing efficiency, strengthening systems, expanding connectivity of equipment, and it's digitizing more of the industrial process, which provides more data for analysis and improvement. Management makes decisions based on real-time data. AI is reducing costs. It defines patterns, uses analytics, and predicts problems. Systems notify maintenance ahead of time, preventing serious expensive problems before they arise through the continuous processing of data streams from sensors. Inside machinery, sensors are listening for noises and signs of wear and problems before they arise. It's improving precision and quality. Teams are resolving issues early on with AI algorithms that are alerting them about potential production errors that could result in quality concerns. Teams are getting information that is not always seen, including how things are used and how well they work in the real world. The information is then used by product developers to make strategic engineering and design adjustments. There's also supply chain improvement with AI as it assists businesses in foreseeing and adjusting to market changes. The ability to make strategic decisions ahead of time rather than responding to issues as they arise is a great advantage. The algorithms are evaluated over time for elements that might impact companies and assist with making time and money saving strategic decisions. Products are often damaged in the manufacturing process, which results in increased costs. With visual inspection systems, damaged products are detected in real time, so defective products are identified and excluded before reaching the final packaging stage. Cracked bottles are detected by visual inspection systems. After being detected, it's removed from the production line. We provide Easy Check Vision Library, machine vision systems, software library. It's easy to use and comes with image processing functions like threshold, filter, rotation, and color channels. It comes with template matching functions, which allow machines to match the similarity of items through vision recognition. It has blob analysis for analyzing location, gravity center, and the area of objects. Optical character recognition allows for recognizing letters and numbers in English, Chinese, Korean, and Japanese. Gauge and measure allows for providing measurements of shapes based on their edges. The 3D image calibration library allows you to unwarp skewed or warped images. A smart sensor is a device that makes use of a transducer to gather a particular kind of information from the physical environment. It takes that data and applies processing capabilities that are built into the sensor to the specific kind of data it's collecting to carry out a planned and programmed purpose. The data is subsequently transferred via a network connection. In order to reduce errors and noise from results before transmitting them to the cloud for collection, smart sensors have a limited amount of memory and processing architecture. Smart sensors have been used to assist with various monitoring tasks, including leakage detection, environmental monitoring, remote system monitoring, transportation, and industrial applications. Smart sensors are devices that use wireless connection, sometimes use wireless connection and embedded processes to monitor, analyze, and maintain diverse systems by the gathering data from the physical environment. They work by using the environmental data, converting that into calculable electrical signals like speed, temperature, pressure, mass, or the presence of a person in the room. Smart sensors have four main functions: measurement, configuration, verification, and communication. Smart sensors are being used in a wide range of applications. They're being used to assist with monitoring tasks, including leakage detection on tanks, environmental and remote monitoring systems, monitoring temperature, humidity, different other elements like carbon dioxide, also used in the transportation and industrial type applications. ICP DAS USA provides smart sensors. Our ISN-101/S2/DIN is a smart liquid leak detection module. It communicates over Modbus RTU. The WISE 5231, our IoT edge controller, it connects to various Modbus I/O and triggers outputs based on inputs. The AR2000 triggers an output based on vibration intensity. It's used to turn equipment like servers in a data center off for safety based on the vibration intensity. The ALM Horn BR is a single input, single output transducer alarm siren with 4 selectable tones. It triggers an alarm based on sensor data. The ICANN 116 is a Modbus TCP-based LED display for displaying messages. Smart sensors are being used in temperature and humidity monitoring applications. The DL100TM485P collects temperature and humidity information, which is collected by the WISE 5231 IIoT edge controller. When the room temperature is too high, the WISE controller uses the IR712 MTCP Modbus TCP-based universal infrared learning module to send commands to power the air conditioner on via infrared to lower the temperature. The NS205 industrial Ethernet switch is used to network the equipment together. The temperature and humidity information is displayed on the ICANN display. Microsoft also provides Azure cognitive services that includes an API for speech to text and text to speech functions, language translation, facial recognition, image recognition, and more for machine learning applications. It has the ability to detect the sentiment in someone's voice. It can also personalize responses and use natural languages. Robots are widely used in industrial automation and are being trained. Their accuracy is increasing. They're using machine learning techniques. Robots are learning through AI how to better perform tasks like gripping items, understanding spatial relationships in the industrial automation applications. They're using computer vision, motion control, and other tasks that are allowing them to better interact with the world around them. We provide IoT Star cloud-based IoT management software for remote management of industrial automation systems. IoT Star is installed on either a private server or a public IoT cloud system. It provides remote access, sensor data collection, and sensor data visualization. The software is easy and flexible to install. No programming is needed, and it helps with saving time, costs, and data storage. So all of the functions and everything, it's all set up just through configurations. It can work with the database for data storage and the querying of information. It can work with SCADA software and allows for status and management over a web browser. It integrates with data acquisition and control equipment. Lots of widgets are provided like line charts, bar charts, pie charts, gauges, bars, values, clocks, timers, and maps. You can apply industrial machine learning by implementing AI with .NET programmable controllers using ICP DAS USA WinPack modules and the ML.NET provided by Microsoft, adding cognitive services like speech, vision recognition, emotion detection, and decision-making in your applications. You can review predictive analytics using Azure Machine Learning Cloud Services and our IoT Star cloud-based IoT management software. Now I'm going to pass it over to Robert, who's going to be going over in more detail the IoT Star cloud-based management software. And again, if you have any questions or any applications you're wanting to go over, we can do that. Please type it into the chat box.
Okay, thank you, Maria. I'll switch over to my screen. Can you see my screen okay, Maria?
Yes.
Okay, let's see. This is our IoT Star page. Actually, let me show you quickly how to get there. So from our main home page, you click on, or I'm sorry, you hover your mouse over the software link, and then IoT Star is over here on the right side under IoT Management. Simply click here, and you get to the IoT Star page. Maria mentioned a little bit about IoT Star, but I'll go over a few more details and show you a live demo at the very end. If you want to demo it yourself, the link is over here on the far right. It simply takes you to the bottom of the page where you can log into the IoT Star demo, which I'll show you in a few minutes. But some of the features of IoT Star, let's see, let me go up here. So this is the architecture for IoT Star. So IoT Star is a software platform that allows you to integrate and share data from many data sources. For instance, if you have multiple factory locations or multiple manufacturing locations, all the data can be shared to the cloud, and then you can process it by implementing SCADA software or other analytic measurements, and use the data from these sources for artificial intelligence, predictive maintenance, and many other benefits to manufacturing. Data analysis allows you to, analyze the data to make smart decisions, to improve production, to manufacture faster and more efficient. Okay, let's see the flexible features. This is the dashboard, which I'll show you some more what do you call it, a live demo on, but many of the features are shown here. The dashboard for IoT Star allows you to essentially create an HMI on your screen to view charts, analyze data, make predictive or smart decisions based on the data analysis. And you can also do what do you call control and monitoring from the dashboard as well. The benefit of getting all the data is that with the data that you analyze, you can make better decisions, and the better decisions are based on, predictive analysis. As Maria mentioned before, the AR vibration sensor can be used to detect possible failure, maybe earthquakes, or what do you call it, sudden vibration that can cause computers or equipment to fail or become misaligned as well. So you can get temperature and humidity data and share that in the cloud so that you can maybe predict earlier failure of machinery due to excessive heat. And what do you call it? You can turn on air conditioning or additional, ventilation to improve that situation. Let's see, scrolling down. This is a similar screen to what I'm going to show you later. It just shows IoT Star's dashboard service and the analytic capabilities. But the next image is probably the more important one. This is a live demo in which it just shows how IoT Star and our PMC and WISE modules can be used to collect data. So our WISE modules are if then else IoT Star servers, which collect data from various portions of the equipment, manufacturing equipment at the bottom. This is a packaging application in which sensors and monitoring devices are used to collect data to enable the IoT Star platform to pick up the manufacturing data for production and number of packages, inspection for defective products as well, and then package them and know the exact quantities. With the IoT Star platform, you can incorporate this over multiple locations and share the data across, many platforms, and this way you can have a better idea on manufacturing at various plants and the efficiency as well. Okay, now I'm going to log into the demo. The demo is shown here. This is the dashboard for our demo. Once you click on that link from our website, you can get to this and view this exact demo. You can manipulate it. You can view what do you call it, maintenance on the equipment. So for instance, the device maintenance. With this demo, there's two pieces of hardware included, the WISE 5231M and the PMC 5231. If you click on the device, you can get to the maintenance screen and modify and what do you call it, monitor the actual device itself by clicking here on the little gear icon. And you can actually log into the web interface of the device here if you wanted to view the device only. But the overall dashboard combines the data from multiple pieces of equipment. Two were shown here, but you can certainly include many, many more and create your own dashboard to visually see the data and manipulate the data into a screen that makes sense for your manufacturing application. So over here on the right side shows a visualization of, like, for instance, a packaging machine, and shows the ability to what do you call it, monitor the power at the various locations. And I'm not sure what the refrigerator's here, but maybe it's just for heating or cooling of something in the manufacturing process that needs to be monitored. But you can view real-time data. So for instance, if we wanted to view the WISE and maybe monitor some of the temperatures, you can view the temperature here. It's real-time data. So let's see, far right will show the actual data being updated as time goes on. So it starts the moment you log in and just will update as time goes on. Since it's temperature, it's not changing very much, but we can view historical data over here. Let's see, where's the historical IO data? You can just see over time what the sensor or temperature sensor that we just viewed was showing. So this is the data from today. And if we want to change it to, I don't know, same day last week, we can do that. At that time it was 74 degrees. You can also do a custom date. So for instance, if we wanted to do, I guess it's only data from a few days, but say we want to do Monday's data, just click on Monday and we can view the data from Monday. Any of the data that is recorded in the module can be shared. So for instance, let me go back to the WISE 5231. So connected to that is a DL 10 or 102. I'm not sure what the 3 is for, but it's DL 102. And from that, you could view the status of the relay outputs for the warnings. The AI, which is connected to the carbon monoxide sensor and carbon dioxide sensor. You can monitor the particles, humidity, temperature, and dew point. So for instance, maybe humidity matters in this production. So you want to make sure that the humidity is consistent over the period which is analyzed. And you can maybe make smarter machine learning decisions based on knowing the humidity and being able to control the humidity of the environment to better manufacture the specific product which you're manufacturing. You can also do power data, which is shown here. With this is our PMC 5231, which is a power monitoring power meter concentrator. So for instance, the refrigerator data you can view here, loop 1. This is real-time data. So again, the data will appear over here as time goes on. Let's see, we'll just wait for a few samples to pop up. So you can see the temperature change and fluctuate, and, or I'm sorry, the power change and fluctuate as time goes on. You can also view the historical data by clicking over here for historical data and doing the same thing, except this time we're just viewing the data from either a certain period, like a day, a week, a month, or a quarter. Let's just do a week and see what the data look like at that point. Just shows average data, monthly, not sure how far back it goes. It's been pretty consistent up until about the 14th, which may be an indicator that, I don't know, something was powered down, likely. But again, this demo is, free, and you can view the demo yourself at your leisure. And we also offer the IoT Star based on tag counts, so you can purchase it based on number of controllers that would be connected. So, for instance, if you had 50 controllers, it would be the 50 what do you call it, controller price, 200 and 500.
And most comparable software has a monthly fee. And so that really differentiates this software because it's a one-time fee. So you don't have to pay every month for this.
Yes, that's a very good benefit, actually, because we also don't offer those maintenance contracts, which for free tech support, we can help you with troubleshooting and setup and configuration as well. At this time, I guess we'll answer any questions that you have. If you have any questions, please type them in the chat box, or if you would like to ask them live, please raise your hand in the software or the Zoom panel, and we'll unmute your mic. Let's see, in the Q&A, I don't see any questions. Does anyone have any questions they'd like to ask live, or if you have any that you want to type, please feel free to type in the chat box, or I'm sorry, the Q&A box. I'll check both, but if you do have, we do prefer a Q&A box. No questions.
Okay, if you have any questions later or applications you want to go over, you can always feel free to contact us by email or phone. Thank you so much for coming to our training, and feel free to let us know any topics that you're interested in having training on or webinars on, or anything that you want us to go into more depth about.
Okay, we all wish you happy holidays, and we'll see you for the next webinar next month in the new year. Oh, actually, I do see a question that just popped up. Let me see. Oh, it just shows, will this recording be shared with us later? Yes, we will post the recording of this video and the slides on our website, probably within a day or so. Okay, any other questions? Okay, you all enjoy your holidays, and we'll see you next month.
Thank you. Bye-bye.